Um, I'd like to call on Dr. Kodagali to talk about the geological model and prospector's guide for polymetallic nodule deposits in the Clarion-Clipperton zone.
Thank you, Chairman. Good evening, delegates. After listening to the legal aspects of the oceans and the resources in the oceans, now I wish to take you to the scientific aspects of the marine mineral resources, especially the nodules. Okay, can I have the first slide? Actually, the authority, as you have heard in the morning, is engaged in an exercise of establishing a geological model for the nodule resources in the Clarion-Clipperton zone. 7 of the 8 contractors of the authority are in the Clarion-Clipperton zone. This is in the Pacific. The major, I'm going to talk on the geological model and the prospector's guide for polymetallic nodule deposits in the Clarion-Clipperton zone. Next. Before I begin, let me, for the benefit of the those who are not initiated into this, get into what are polymetallic nodules. Polymetallic nodules, or the ferromanganese nodules, are small, typically pea to golf ball sized deposits that exist in the deep ocean. They were first discovered on the ocean floor in the 19th century, contain relatively high percentage of metals like manganese, iron, nickel, copper, and cobalt. That's how a single nodule looks. Yeah. Next. Where are nodules found? Nodules are found everywhere in the area. By area I mean beyond the exclusive economic zones. We have them in the Indian Ocean, in the Pacific, in the Atlantic, everywhere. These deposits, the nodules are found mostly in depths beyond 4,500, 4,000 to say 6,000 meters depth. And that's why mostly they are not found in the exclusive economic zone of the countries. Except for one instance, in the case of Cook Islands, we have what can be said as semi-commercial type of nodule deposits. Next. This is how a photograph of the underwater photograph of polymetallic nodule looks. This may be an ideal one where the distribution is quite dense. It may not be the case always. Actually, the distribution of nodules is represented as kilograms per square meter. We have equipment, as I said, they occur at depths of 4,500 meters and beyond. So it may not, so we have to rely on the equipments to get them up. So what we have is the equipments like the free fall grabs, the photographic equipment, and the corers, so the box corers or the spade corers, which help in getting the nodules up. As I said, they are indicated as kilograms per square meters. We find on the ocean floor, deep ocean floor, nodules covering area of up to, say, from nil to up to 25 kilograms per square meters in the maximum in some cases. Next. As I said, we took this work on the establishing a geological model because, as I said, we had this lot of 7 of our contractors are in the Clarion-Clipperton zone. The large area is covered. Then we also had other people who will be interested in going in for the nodule exploration. So we wanted to establish a guide sort of thing which will help the researchers, which will also help in understanding how the nodules are formed, how the nodules are distributed. So with that in mind, a program was initiated. The first of the objectives was to improve the resource assessment of the Clarion-Clipperton zone, integrate available resources and related environmental data, then provide useful guidelines for prospecting and exploration. Next. So as I said, the area of interest is quite huge. These are the 2 fracture zones, the Clarion and the Clipperton. Within this are the, like you have seen the map presented by Mr. Lodge before me. All the 7 contractors and the reserved areas lie within this. The area which we covered for, which we used for this model studies was between 110 to 160 degree west longitude and 0 to 20 degree north latitude. That means it's an area of about 12 million square kilometers, which is very huge. I don't think there has been any attempt in any part of the world to model resources in such a huge area. We could undertake this because we had the resources available, means the data available for this region. And that's why we thought that it is incumbent on us to develop a model for the nodule resources in the area. The next. The program team, we had 3 clogs in the wheel for this program. The secretariat, which is based in Kingston. The next, the consultants, we had engaged the services of consultants who had worked on the nodules over the years for past 30 years in the Clarion-Clipperton zone. Then the contractors, like I said, we had 7 contractors in the Clarion-Clipperton zone. So we sought the help from the consultants and the contractors. Contractors provided with not only the data which given initially, and also the data which they had additionally collected later or collected in the areas which was not actually allotted to them. They readily agreed to provide that data. Then the consultants helped us in getting the additional data which was available in the public domain or with the other organizations. Then they also, the contractors also provided the services of few of the experts to work on the project. Then Secretariat acted as a conduit for the contractors and the consultants to work together. We established the entire management of the program was done through the Secretariat, though we had the consultants to work on that. Next. The major milestones were the draft reports. The project was initiated sometime in 2005. The draft reports for the first stage were ready by July 2006. The mid-course meeting we had in September 2006, wherein we evaluated the work so far and then adjusted the program schedule in such a way that we tried to take more work from some of the consultants, and we also had to abandon some of the proxies which were not giving us any further results. So then we had the interim reports which have been coming and which are almost ready with in the year 2007 and 8. The final reports are expected by early 2009, and the final workshop will be held sometime in the middle of 2009, which will culminate the project. And all of our outputs expected from the projects will be presented in the workshop during the middle of next year. Next. The two of the main outputs from the program are a prospector's guide and a geological model. The prospector's guide is supposed to be a guide for all of the future explorers who wish to explore not only in the Clarion-Clipperton zone, any world oceans looking for the nodules. If they find something which is like a proxy which I will explain later, if they can find that, and then there are chances of finding nodules in those areas. So we are going to, like a guide for the nodule exploration we will be publishing. Then there will be the second aspect will be the geological model itself, which will explain the distribution patterns, the resources, and all other aspects related to the nodules. Next. The program implementation strategy was to assemble data sets. Initially what we did, in fact, the project was initiated when Dr. Kaiser D'Souza was with the authority, and he was instrumental in bringing all the contractors and others together, and then getting all the data which was available additionally with the contractors to the table. Assemble the data sets, consider for use in the geological model, use as proxy variables in the model, incorporate into the narrative, document the sources and methods. So we have completed all these stages. Now we are in the final stage of publishing the prospectus guide and publishing the geological model. Next. So the ISA's role, apart from acting as a central cog in this project, was also to establish a FTP and a VPN, that is the virtual private network site, and a file transport protocol for the consultants and the contractors. This we did as a secured one, which was only open to the contractors and the consultants. The bathymetry data from the public domain was put on this. Additional data acquired from the contractors for the program. Data and reports submitted by the consultants. And we also had the old bathymetric maps provided by the then pioneer investors. They were digitized and geo-referenced and also put on the VPN site. Next. The next part was we had directories for each of the consultants wherein they can place their reports, data, etc. directly. Reports and data submitted by consultants, contractors. Then for contractors and contractors data, from the main data provided by the Interocean Metals, COMRA, that is China, CORDI, that is Korea, DOT, that is Japan, the data was put on that, and the reformatted data for use of consultants. Because we reformatted the data so that the consultants can use this data as they need. Next. So we had, for the model, the data collection was for the proxy data. We had the data on bathymetry, the tectonic and volcanic data, sediment data, nodule morphology, water column data, biological data. Then for resources, which was one of our major tasks as far as the program was concerned, to estimate the resources again for the entire Clarion-Clipperton zone, we use the abundance, manganese, nickel, copper and cobalt values. Next. So I will go through one by one the proxy data of bathymetry. This was actually analyzed by Professor Lindsay Parson from the Southampton Oceanographic Institute. The base data was the general bathymetric chart of the oceans, or the GEPCO. Then the contractor contributions came from China, from IOM, from Korea, who provided graciously the multi-beam data, which is a much more detailed data than the GEPCO data. Then we used all this data, and a 1 minute data for the entire region was generated. And for specific areas, about 7 areas, we had 0.5 and 0.1 minute data. And we generated reports, fly-throughs, and GMT grids, etc., which have been put again on our site. When we publish the report, I think this will be one of its kind in the sense that such a detailed data in one big area has so far not been reported. Next. So as I said, this is the region, and we had the bathymetry group which generated the 1 minute bathymetry data. You can see that in fact the central region, with the Clarion, between the Clarion and Clipperton zone, we don't have much of the variations. We see this is mainly because the data used for this is GEPCO. Next, we will have some of the specific areas. This is next. This is one of the specific areas with 0.5 minute grid, wherein you can see that there are a lot of features which have come out from the data which we are going to publish. This is one of the areas where the multi-beam data was made available by one of our contractors. Next. This is again a half a minute grid with a search radius of 10 kilometers. The gridding was done, which is a fairly large area of about about 10 degrees by 5 degrees. Which is the large area which has been again mapped using the 0.5 minute data. Next. This is again one of the half a minute grid data. In like I said, we had detailed maps for 6 of the areas. Next. Yeah, then let me come to the resource assessment. We had the data which was provided by the contractors, which was available with us in the reserved areas, which was in fact which is the property of the authority. So we used that data. Additionally, we also used the data which was provided by the contractors in the areas which were not belonging to them, or which was collected by them later and which they were ready to part with. So that data also was used. Next, I will show you the amount of data we had. Next. We had the data source from CDR, that is our own central data repository. Then from Korea, UMCO is one of our consultants managed to get hold of the data from this multinational who was working earlier in the area. Then China, Interocean Metals. So we had for the abundance data more than 61,000 stations data, which was used for our resource assessment. Similarly, for the chemical assay, we had for manganese, cobalt, nickel, and copper around 8,000 station data. Next. The elementary statistics of these data which we use for this analysis, like I said, the number of cases were around more than 60,000 for the abundance, and for analysis of manganese, copper, nickel, and cobalt, we had more than 8,000. Next. Now I'll show you the total resources which we estimated in the area. The mean abundance is 5.58. Like I said, the abundance ranges, the maximum goes up to 24. The manganese is this much, and cobalt and nickel and copper. And we had a total tonnage calculated in the entire Clarion-Clipperton zone. It's not in the reserved areas, it is in the total area of which we work for this program, 27,063 million metric tons, which is mind-boggling number. If you say cobalt of 58 million metric tons, nickel of 340 million metric tons, and copper of 290 million metric tons. That would be much more than the total land resources available today. In fact, each of the contractors has 75,000 square kilometers of area with them. So each one of them can sustain at least four to five mine sites, which will run for 20 years. So that's how huge the resources are of the nodules in the Clarion-Clipperton zone. In fact, even in the case of Indian Ocean, also the nodule resources for as claimed by India are also to the tune of 500 million metric tons in the 75,000 square kilometer area. Next. So with the help of the kriging, the statistical analysis was done based on the available data, and consultants have generated several maps for the entire Clarion-Clipperton zone. The kriging method was used for generating these data. This is for the nodule abundance. I will, in fact, because of the paucity of time, so that we have time left for discussion, I will run through some of these maps. If any details are required, I think they can come to me. I will give more details. In fact, we have more maps available. In fact, when we will publish, we will have greater details of the calculations and how we have done it. Actual data we may not be putting on the reports, but all these results which I am presenting to you here will be presented as part of our geological model documents. Next. This is for the cobalt. Next. As for nickel, I'm sorry, that is not kilograms per square meter, it is percentage. Next. Again, copper in percent. Next. Then what we did was also, apart from kriging, a quarter degree grid for the entire Clarion-Clipperton zone. The nodule resources were, the nodule abundances were calculated. This is one of those data for the cobalt. Next. Similarly, we did it for copper, manganese, and nickel. So this exercise was completed just this year by our consultant. Next. Then the proxy data of tectonics and volcanism. So the contractors, we use these, like I said, apart from bathymetry, we use several data which may be an indicator to the occurrence of nodules, and also a pointer to the distribution of nodules in the area. We use several proxies which can be of help. One of that was the tectonics and volcanism. So we used the data from contractors. Korea provided with 8 areas of gravity data. Ujmur Geologia, that is Russia, provided with the entire gravity map of the Clarion-Clipperton. Then the analysis was done initially by Professor Kazmin and Professor Yubko. The interpretation was done by Yubko and Dr. Kotlinski, who's here, who will present the results of the IOM work tomorrow. Next. These are some of the maps which the volcanics and tectonic group generated. This is the gravity anomaly map. This is the Clarion-Clipperton zone bathymetry map. In fact, this is the this is an improvement. Again, it is the same as what Dr. Parson had developed. Next. We had the volcanic and tectonic ridges which were identified by the consultants. Then the volcanic and tectonic map of the area, which was identified using the bathymetry and the gravity data. Next. Then the earthquake epicenters, which were recorded recently, have been mapped. Based on that, the seismic lineation map was generated. In fact, the analysis of and interpretation of this data is already complete, and the report has been submitted to the authority, which will form part of our geological model document. Next. IOM has also worked on the lithology of the area, and a lithological map was produced by them. Next. On nodule morphology, that is one of the proxies which we try to use, in which way it will relate to the distribution of the nodules. The nodules have differing morphologies. The shapes differ, the sizes differ, the outer surface differs. They are smooth or hard or rugged. Based on that, the analysis was done by IOM again, and also by Cordy. The data was provided by Comra. Lockheed size distribution and abundance and metal content. Korea provided the morphology, texture, and size database. IOM also provided with their own data. Next. The IOM recently submitted a report on the nodule coverage, morphology, and distribution in the eastern part of the Clarion-Clipperton zone. Based on 926 station data, they made available this report. The discoid type of nodules, they say, dominate in the area. Then the distribution of nodule types shows zonality in the distribution. Next. Then nodule abundances versus size was also studied by Cordy. They have also submitted a report this year again, which is the final report as far as the morphology is concerned. This is the relation between the dimension of the nodules and the nodule abundances. Next. The next proxy data we used was the water column data. For that, again, IOM used this, provided the data. Korea provided the data. Then analysis is underway still, and part of that is already completed, and the final report is under preparation. Next. The main data we used as far as CCD is the carbonate compensation depth. In deep waters, what happens is that beyond a certain depth, the carbonates don't exist. Means they are dissolved because of the pressure. And we find that nodules normally occur beyond the CCD, that is the carbonate compensation depth. Normally in the areas where the carbonates are there, the nodules don't occur. So we use this data of the depth of wherein no carbonates are found. That data was collected and from different sources, apart from the data provided by the contractors, also by the data available in the scripts and the Woods Hole Institutes. That was collected and analyzed by Dr. Cronin, and he provided the maps for the CCD. Next. We also use the depth minus CCD as a factor for the distribution of nodules. We find a good relation between that. Next slide will make that much more clearer. Next. The nodules normally found in, are found in these regions below the CCD or the carbonate compensation depth. Normally don't find them here, but the main area we find the nodules is this. So this we again show graphically next. There's a potential relation to CCD for increasing nodule abundances on one scale, the increasing productivity on one scale, and the decreasing depth. So that's how we have a relation between the CCD, the abundance, the productivity. Next. We also used, as I said, the depth minus CCD versus abundance as I said, normally nodules are formed just below the CCD between depths of just minus 200 to 600 to 700 meters below the CCD. So this data was analyzed by our consultant.